The
Broadcast you.
broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody, and happy Friday. Thanks for joining us for today's TopSolid webinar with a key focus on machine components. So far, we got a good amount of people that have shown up. We have a bunch more that have registered, so we're going to give them a few minutes here. So while we wait, I'm going to go ahead and just run a little simulation here and begin talking about what the goal is today. So in TopSolid, if you're a TopSolid user, you know this already, we do full machine simulation. Okay, we use machine simulation for many things. Amongst that is collision detection, making it look pretty, good setup sheets. There's all sorts of fun, good reasons for this. Some people struggle with doing their tooling in a system like this because it can take a lot of work. So what I'm going to hopefully show you today is that you can work a little bit smarter by using some of the technology within TopSolid, primarily in this case, machine components. Machine component basically allows you to define a holder or a chuck, for example, that you're going to reuse over and over and over again and capture what it's for and then make it simple to just drag and drop to include it into your machining environment. So this is the project we're going to be working on today. It's a little Mazak machining center. You can see I did a little part transfer there at the end just for fun. And I think everyone that's going to be here should be here. So why don't we just get started? As always in our webinars, I have the TopSolid USA staff present. If anyone has any questions, go ahead and type them into your question section, and one of my teammates here will try to answer them, or they'll bring them to my attention so that I know to comment on them during the webinar. So here we go. All right, so if I zoom out here, you can see a little machine def. Again, this is a little Mazak quick turn 200. In here, I have holders. These holders were downloaded from the Machining Cloud, actually. If you're a Machining Cloud user, you can grab these from the Machining Cloud. Mazak has generously put all of the solid models for their holders for turrets onto the Machining Cloud, and you can download those in a neutral format. So where we're going to start today is talking about what a machining component is, and then I'm going to go through how to define a machining component. And we're going to do this in a couple of different ways. The first way I'm going to do is when you don't have access to a solid model, you're only given a DWG or DXF. So I'm going to import a DXF file and show you the steps it takes to convert that DXF into a solid model. Then we'll take that solid model, turn it into a machine component. Then I'm going to import some solid models and again, show you the steps you should take to turn those into machine components as well. And if time permits, we'll even go over how to define a chuck. Okay, so let's get started. I'm going to go ahead and save this for now, close it up, and I'm going to go ahead, minimize some of my work here, and we'll just go here and import some data. So what I'm going to start with in this case is importing a file. Now, if you're a TopSolid user, you can of course go import export, import file with conversion. Okay, you can browse to wherever your files are, or if you already know the file you want and you have it open in Windows Explorer, for example, you can just drag and drop out of Windows Explorer into the folder in your project you want to work with. So if I drag and drop onto there, it comes up and asks me, do I want to convert this? I'm going to say yes. Like I said, we're going to start with a DWG DXF file. Again, this was off the Machining Cloud as well. You can get them as solid models or as DWG DXFs. This has everything I want, so I'm just going to go ahead and green check mark. One of the reasons I'm choosing to do it this way to start with is also kind of to introduce you to the steps it takes to convert something like this into a 3D document. The other thing that I want to talk about, you saw in my simulation, you saw my machining components. They were quite detailed, in fact. The big thing I will tell you to save on calculation times is only include details that are important for collision detection. Okay? If it's an internal component, get rid of it and simplify it. Okay? If it's not going to ever run into anything, get rid of it and simplify it. It just makes it easier for TopSolid to do its job. Okay? So that said, here is our 3-view drawing. First thing that I want to do on this, I'm going to go look at my layers and see how the imported layers came in. It looks like I have a dimension layer, that's cool, and I have the regular geometry layer, also cool. To use some of the automation I'm going to use, I want to get rid of these dimensions. So what I'm going to do, this all came in as a sketch, so I'm going to right click, edit, and I'm just going to start window selecting and getting rid of geometry that I don't need. Okay, so we're just going to do this nice and quick. We'll zoom up here, get rid of you and you and you, perfect. Get rid of that, get rid of that, and I'm just hitting delete on my keyboard for those of you that are curious to know that. We'll go here and here, perfect. So we've gotten rid of everything we need out of there, and now I'm going to create a new sketch. Now, maybe some of you have used this command before, maybe some of you haven't. There's a command here called Contour Wizard. Contour Wizard's pretty cool. There's two modes to it. There's path. So for example, if I start here and I'm going that direction, you can see I can choose where I want to go. Okay, it just depends on how you want to create the path. Now in this case, I want the entire outside profile of that 2D DXF. So if I use my contour wizard and I go to this mode, which is region, and I just select near the outside, notice it automatically finds everything I need there. Now, before I finish this sketch, I'm going to do two things. One, I'm going to add a point right there. That's just for the reference 0 point, and you'll understand that in a minute here. And two, I'm going to simplify out and get rid of this spacer block. I don't want to use it. So I'm going to drag a window around like that, hit delete. I'm going to zoom up, get rid of that one. I'm going to zoom up, get rid of that one. And then we can, let's grab that point and let's drag and drop it onto that point. And you'll see TopSolid auto extends, finishes that section off. Okay. If you wanted to, you can add that back in, but again, talking about simplifying and getting rid of things that aren't important, that's going to be my choice. So I'm going to right click on this, choose segment removing, simplify that out, and my first sketch is done. Now I'm going to repeat this process a few times, getting the outside profile, creating my point. I want my point to be right there. Okay. In this case, I'm going to leave this and you'll see why here in a sec. I'm going to create one more quick sketch on that XY plane. We'll go here. I want the outside. Again, I don't need any of that. So I'm going to delete that. I'm going to select this, delete that, drag and drop that over to there. Oops, missed. There we go. And then go add my reference point. So what is this reference point all for? Basically what I want to do is I want to bring these three sketches that I've created. So if I turn all that off, I want to bring these three sketches all up to that point, and then I'm going to rotate them into position so that I can quickly use these sketches to make the solid model of the holder. So here we go. First things first, I'm going to go to my construction tab here, and I'm going to go to transformation. And I'm going to transform this sketch as a linear or translation transformation, and I'm going to use from point A to point B. I want to go from here to there, right? Now, we could use transform, or you could use duplicate. Either would work in this case, okay? So I'm going to transform that to there. I'm going to leave this push pin like so, and then I'm going to do the same thing from here. We'll do another transformation, translation, this time from this point to there, green check. And now I'm going to take both of these two sketches that we just transformed, and I'm going to rotate them. Now, I can't use one of my standard axes because that's where they are down there, so I need to define a rotation axis. So I'm going to say axis by point and direction. I'm going to use this point relative to the x-axis, and we'll say 90 degrees, like that. That's going to stand up my sketch. And then I'm going to take this last one, do another rotation. Again, point and direction, this time by Z, right? 90 degrees, perfect, done. Okay, so we have our three sections rotated and moved the way we need them. Now I'm going to take this one and extrude it. Now, I have no idea how high to extrude it, but I don't need to know because I have my other reference sketches, right? So I can just switch to point, for example, and extrude to there. Perfect. Next, I would like to go to my shape tools, trim by profile, and here I'm going to trim using this sketch to start with, referencing the same plane of that sketch. Oops, we want to use sketch 4. Sorry, we can reference that plane, good enough. We want the arrow to be pointing out. We'll let it hide tools for now, that's fine. That's good. And now let's go by this one here, arrow pointing out, and we're good. So we have the main shape of our holder very, very quickly. Now, let's go back and find sketch 3 here, because I do want to put the base on here. And the reason I want the base on here is if we use this in a setup sheet, I want it to show the holder properly. That's all. It's not going to do anything for collision detection because, as you know, that part is going to be in the turret anyways. So what I'm going to do here is I'm going to define a new sketch. I want the sketch to be on the same plane as that curve. And I want the origin point of the sketch to be my origin point of my curve. This simplifies everything a lot, okay? And now I'm going to start by selecting some things here. Let's go to, let's do path between two edges and we'll choose border, okay? So if I select this, going down that way, and I go to here, that's gonna grab all of those curves. Perfect. I'm gonna grab this, and why not that edge as well, okay? Now, from here, I'm going to delete that constraint, drag it out some. I'm gonna zoom up here, delete that constraint, drag it up some, and now we can just do some quick trimming. So I want to trim that side and that side and that side, that side, and that side. Like that, we now have what we want. If I go and turn off sketch 3, you can see what's remaining. Again, to keep things simple, I'm going to actually window select all of that and use segment removing just to simplify that a little bit. And now like this, we can just go ahead and create a quick revolution. We want to revolve about that. Perfect. And the final step here is we want to unite to that shape, this shape, and we now have the solid model of our holder. So hopefully you can see, just working with the DXF file, it was pretty efficient. We got the general sizes and shape of our turning holder. So the next step now is to prepare it for a machine component. While I'm doing this, I'm also going to plug our training programs. We have started an online training series of training courses that are available. One of the training courses that we're about to release has to do with machine components, and it goes over detailed instructions on how to create them, manage them, and everything. So in this webinar, I'm just kind of giving you the highlights, but if you're interested in that training, reach out to one of your sales guys, and we'll be happy to sign you up for that class. Okay, now, when it comes to defining a holder for TopSolid, the thing that you have to understand is a little bit about your machine definition first. So I'm going to go ahead and open up a machine definition really quick. And I want to explain a few things. If we look on my turret here, you can see there's a bunch of frames, okay? If I hide what you don't need to see, so let me just hide this right now, and we'll hide that. This frame is your mounting frame for your holder. If you notice, the X yellow, Y purple, blue is Z, XYZ here is oriented just like the main spindle or the machine zeros frame. That's super duper important. You need to understand how the machine definition is done that you're building a holder for. In 99% of machines, I would say this is always the case. Okay, maybe in some unique conditions, the frame orientation is different. If it is, you need to make sure you understand that orientation when you're defining the matching frame on the machine component holder. Okay, so think of that in that position. Now, we're going to go back to our solid model, and I'm going to define that first frame. So I'm going to go to my frames, and I'm going to do frame by point in two directions. And I'm going to say my 0 point is right there. What I like to do is kind of orient the part or the holder like it would be assembled into my turret, right? And remember that your Z is going this way down the machine, X is going in that way. So I want the X axis of my holder frame going along that shaft. And I want the Z axis going opposite that direction. Okay, obviously make sure that that's squared up the way it's supposed to be. But now we have the same orientation, and let's show these both next to each other. Let's drag that over to there. Okay, and we'll zoom up on the frame. And again, sorry, I should have left this turned on. So let's just hide all this stuff again. Get it out of your way. So if we look, X, Y, Z, X, Y, Z, everything is oriented perfectly. Okay. Next, in order to define the right frame for the tool holder itself, for your turning tool, for the stick tool, you need to understand something about turning tools. So let's see if I can show you a thing or two there as well. So here I have, let's go to here, machines, universal tools, there we go. Here I have a left universal tool. This is one of the universal tools that you can use in TopSolid for defining a turning tool like this on the fly. Okay, and I just grabbed these as a quick way to showcase them. So if I go into the functions here in my entities tree and I go to my tooling shank here, that is the orientation of the frame for a left-hand tool. Again, to be placed in that holder, if I orient it the same way, it needs to look like that. If I go to my neutral tool, you can see the neutral tool has a very, very similar, actually identical orientation to left. If I go to my right frame or my right turning tool, this one's a little bit different, okay? If I go to my functions and I turn this one on, okay, because that tool is going to be put in that way. Notice where X is pointing this time and Y is pointing. They're inverted or opposite of the other holders, okay? So again, you just have to know and understand the tooling that you're using. Now, this is the way the universal tools are described out of the box from TopSolid. If you defined your own tooling library, check how you defined the tooling shank orientation. I can't stress that enough. If they don't match, you're going to not get the results you're looking for. All right, so let's close everything but that document. Nope, don't care. We'll switch back to here. And let's make the two additional frames that we need. Okay, now first things first, we're going to go to our construction tab here. Again, we're going to go to frame by point in two directions. I want to put this frame at the intersection of that edge and that plane. Okay, why? Because this is the y-axis of the machine, right? And we want the holder to come in so that the cutting tip is right at y0. Again, if you don't, and your tool is shifted in y positive, y negative, TopSolid will include a y shift to move that point back into the right position. Okay, so let's green check there. And now for our left and neutral frame, we want the X direction facing out, and we want the Z direction following that. Okay, perfect. Let's go make one more for the right-hand tools. This time the X direction is inverted. That's it. Z is still facing down that direction. Last step I'm going to do is I'm going to publish these frames, and I'm going to publish them with specific names so that I know what they are. Okay. If you want to, you can even, before you publish them, you can come here and you can name them. Okay, so I can go and rename this one to be mounting frame, right? I can name this one to be left or neutral tooling frame. And then I can rename this one to be right tooling frame. I'm a big fan of naming important elements that you create in the software, because this way, when you come back to them later, you can know what they are just by reading. There we go. Last step is we're going to do some publishing. So again, if you're new to TopSolid, publishing is a way to tell TopSolid to bring something forward when you include this object into another document. Okay, so let's go to publish frame. This one is going to be mounting frame. I am just going to simply copy and paste as my published names. I'm going to go here. That's our left or neutral frame. We'll copy, paste, and we're going to come over here. Now, what I'm doing here by publishing the frames is I am describing everything that's important in the part document. When I go to my machining component document in a minute here, I'm going to show my publishings, and this way I can just use all those objects in the machine component document. So let's have a look. I'm going to go here to my holder folder. I'm going to start a new document. Machine components are not a quick access document type because you don't make them every day. Go to the Advanced tab, choose Machine Component, hit our green check mark. First, what is this? This is a radial main spindle turning holder. Okay, who makes it? This is by Mazak. Awesome. From here, I want to simply drag and drop, include that into this document. Again, I'm a big fan of always orienting my views so that I'm thinking the way it goes into my assembly for the machine, right? I'm going to right click anywhere on the part. I can go to publishings and hit show publishings. This brings those frames that we already created forward. And then last thing I'm going to do here is on my machine manager here, I'm going to expand it. I'm going to come up here and go to preparation stage, expand elements, and I'm going to edit the ground group. So you can right click edit, or you can double click on ground, whatever you want. Okay. Now, this object is going to be, pardon me, I'm just looking at my other screen here for a second. This is going to be a tool mounting system, I believe. Yep. So we go to tool mounting system. We go to mountable accessory. I'm just going to call that T. This is only for turning tools. The mounting frame, this is how it assembles it onto the turret, is that. I'm going to go and edit that item. This is going to be called left/N, and this is going to be that frame, my left/neutral tooling frame. I'm then going to add another one, and I'm just going to call it R, and this is going to be that frame. The reason I have two in there is because this way, because the frames are different for my right-hand tools versus my left and neutral tools, I can put either or tool onto this holder. Okay, green check, save, machine component, done. Now, how can you use the machine component? Well, let's go look. Let's go to my template folder here. Here I have my template with my quick turn on it. And you can see I have some holders and tooling already defined in there. Let's take this holder that we just created, drag and drop it onto the pocket I want to put it on. Notice it's right there, right? I can, of course, come through here and we can switch it. Let me zoom out so you can see, to be on any of those pockets. Just leave it on top for now, just for fun. We'll green check. That holder has now been included. If I go and let's go ahead and turn off the machine body. Let's see if I can find that really quick. Turret. Is it just the ground? There we go. Spindle Z solid. That's good enough. We can see better that way. Okay. So if I go and add a tool to this now, let's go look and see what we see in here, right? So that's pocket 5. And if we look in pocket 5, notice it's created 2 T5 calls. Again, you're only ever going to use one of these, okay? But notice it says T5-left or neutral, T5-R. So depending on the orientation of the tool you want is the pocket you're going to choose. For example, if I go here to left or neutral, I can then come up here. I'll go to external turn. I'll go to templates. Maybe I want a D series left-hand tool, double click. It's now put that in there, whatever size is there. I'm going to come here and say this is 1 inch, right? We'll say maybe that's 4 inches, 5 inches. I like that better. Okay. And if I rotate this down so we can see a little bit better, here's our tool. I'm going to shift it by roughly half the tool width, so minus 0.6, oops, pardon me, 0.6. There we go. And then you can play with the gauge distance in here. But now you have your holder, you have your tool. It's all the way down right now. Of course, you can stick it out further, do with it what you need to do. But you have now created a reusable machine component, and you've now loaded a tool on there. And what's even better is I just did this on my template. So now this tool will be available every time I use this machining template now. This makes sense so far, I hope. Let's maybe look at a milling holder example. Okay, let's see if we can bang something out there really fast. So to do a milling holder, it's very similar. Okay, I'm going to go back to my folder here. I'm going to back up, go to milling. And in this case, let's do a axial holder. Okay, so I'm just going to drag and drop that onto my holders folder. I'm going to say yes to convert. I'm going to convert everything as a part file because that's all I need it to be. Alrighty, and if we have a look at this, there we go. Now, anytime you import data, you always want to check it. So let's go to Surface tab, let's go to Heal, select this, hit the blue arrow, no invalid shapes, good, blue arrow. May as well try simplifying, see if we can ease up the information a little bit. That's good, still good, fantastic, okay? Now, if you wanted to simplify things on here, for example, you could also use the remove command. For example, I could be on remove, and let's say this is not necessary, rip that off there, okay? You could remove these posts out of here, you could remove that out of here, you could remove anything that really is unimportant for the sake of collision. Now, because this is a webinar and we only have so much time, I'm just gonna kind of fast forward through what I want to be. Now, this tool, you need to figure out which way it gets oriented on the machine, okay? For argument's sake right now, I'm gonna say it gets oriented this way with the coolant coming from the sub-spindle side. So I'm orienting it that way, and I'm just gonna start by making my frames. So let's do frame by point in 2 directions. I'm gonna go to there. Again, in this case, we want the x-axis to be down the mounting shaft, and we want the z direction to be in that direction, okay? From here, we now want to make the tooling frame. In this case, we want the Z to be that way, and we want the X to be that way. Okay? So there's your orientations for that. Again, look at your cylindrical tooling holder definitions to look at the orientation of the frames there. That's how you determine this. Okay? Now, I'm going to go ahead and publish these just really quick here. So I'm going to call that assembly frame. And we're going to call that tooling frame. Helps when you can type 100 miles an hour. And now we're good. Let's go ahead and make our machine component. So let's go to new document. We'll go down here to machine component, blank template. And let's call this radial milling holder. Also by Mazak. Perfect. And let's go ahead and bring in, where is it? There it is. The right tool. Let's show our publishings, right? And then let's go ahead and do the definition. So we'll go to preparation stage, expand elements. Again, this is going to be a tool mounting system. We'll go to mounting accessory. I'm just going to call this a T. It's not going to allow turning, but milling and drillings, and I'll say 1 to 6,000 RPM, let's say. Our assembly frame is that frame. And then we go here. I'm just going to call that T. That's our tooling frame. And I'm going to point this out here. This is a new feature of 7.14. Some of these holders, these milling holders that you throw in a turret on a mill turn machine, sometimes have to manage reversing the spindle direction. So calling an M3 actually rotates the tool counterclockwise and vice versa. So if you have a holder that inverts the spindle directions, you want to make sure you choose this in this definition. Okay? Again, know your machine. That's it. That component is done. Let's close. Let's close. We'll go ahead and edit this really quick. And let's throw that in there. So if we go to our radial milling holder, right? And I just pop it right there. Notice the coolant, sub-spindle side, like I said, that position's great. If I come in here and I go to my tool, let's go down here. This is pocket 11, it looks like. Awesome. And let's say in pocket 11, we wanted to put a twist drill. Who knows? Okay, so a double click. Notice that this is showing a holder. If the type of tooling system you're putting in accepts quick change tools like this, you're all set. If it just is a collet-based solution and you just need the stick tool, make sure you go to templates and choose just the stick tool. Then you can set it to whatever you want it to be. I'm going to say it's a 1/2 inch, 1 1/4 of flute, why not? 3.5 inches long. And if we go here, you'll notice that you have, of course, the ability to play with its gauge distance. Perfect. And now we have another new tool and a new holder combination. And you can reuse this as much as you want. Now, looks like we're coming to the end of our 1/2 hour. I just figured I would show one more quick thing just to kind of give you guys ideas, and this is more that will be taught in that class I spoke about. As far as using components efficiently, you want to put them in a library. Okay, test them first, make sure they're right, then throw them in a library. And then to make the deployment of them even faster, you can create saved searches. So for example, if I go down to my tooling here and double click on my generic turning holders, you see I have a library of all of my machine components that I've created, and I can just drag and drop straight out of this into this file to use them. This way you don't ever have to go look for them again. You're using the power of TopSolid PDM to do the heavy lifting for you. Cool. Well, as I said, we hit the end of our 1/2 hour, so I'm going to call that done for today. I hope that everyone that did attend learned something today. If you're interested in signing up for that new training course, let your TopSolid sales rep know. We'll be happy to get you taken care of. If anyone has any questions at this time, feel free to throw them out there. I'll give a second or two to see if anyone pops anything in there. Otherwise, have a wonderful weekend, and be sure to check the webinar next week as well. See you guys then.